Okay, so today we're going to look at section 4.9, quadratic systems. Systems of equations, remember, is just two or more equations where we're looking for their intersection, which is a point that when plugged into either equation yields a true statement. So the first way we can do that is by substitution. So let's write that up there real quick. 4.9. Quadratic systems. So let's get two equations up here. Y equals, let's look at negative x squared plus 5x plus 6. And then another equation of x plus 6. So we notice first off that the first equation is a quadratic, the second equation is a line. I need to find the solution, or their two intersection points. So the first method we're going to use is substitution. So we're doing this algebraically. If I know that y equals x plus 6, then I'm just going to come up here and plug that in for y. And then use my algebra to solve a simple quadratic. So this becomes x plus 6 equals negative x squared plus 5x plus 6. From there, I just combine like terms and solve. So I'm going to go ahead and add the negative x squared, so it becomes positive. I'm going to subtract the 5x. So x minus 5x would be a negative 4x. And then I'll subtract 6 and subtract 6, which ends up giving me a plus 0 equals 0. So to solve this, I have a simple binomial that I can then factor out an x. And my two solutions would be 0 and 4. Now keep in mind, you just found x values. You didn't find points that where these two or the line and the quadratic cross. In the past, we've been solving quadratics for x-intercepts, but in this case, I have two equations. I'm looking for where they cross. So to find that, I can pick either one of my two original equations and plug in for. This one sure looks simple, so I'm going to plug into that one. So I end up with y equals 0 plus 6. So y equals 6. And then when I plug in the other solution of a 4, I get y equals 10. So my 2 points of intersection are pretty easy. I just put them together. 0, 6 and 4, 10. And you are done. You solved that system by substitution. Now what we're going to do to show you this is that we're going to go ahead and look at your graphing scratch pad and put that in there to show that you can see this graphically also, because really that is the second method. You just would graph them and then use your calculator to find the two intersection points. So let's switch over to my calculator and let's type in our two equations so we can look at them. I have to hit tab, and I have negative x squared plus 5x plus 6. So I have a quadratic opening down. Now if you can't see it well enough, you can zoom out. So I think I'm going to leave it like that for now. Hit tab, and then we have our line of x plus 6. And sure enough, I can't see both intersection points. So what you have to do is just menu. This is going to be important as you're working through these. If you can't see the intersection points, you have to change your calculator so you can. So I only had to zoom out once. Now that I can see that, I am just going to, just like I found my max and my min and my zeros, it's under menu, analyze graph, find the intersection, and then if I want to find this intersection first, I have to click to the left of it, drag it across, click to the right. And sure enough, 0, 6 is one of my intersection points. And then menu, analyze graph, intersection, click to the left, and click to the right. So throughout your homework or in-class work, now that I'm gone, you're going to have a few that say solve by substitution. So you're going to show your algebra and solve, and I'll show you one more of those. Then you're going to have one that says graph to find the intersections, and you can just put them in your calculator. You have to make sure it's y equals, which I think most of them are, and then do that, which is menu, analyze graph, click to the left, click to the right. Okay, well, some of these are systems of equations that are inequalities. So these are really easy to do. I just need to show it in your calculator to you. So let's go ahead and clear out our graphs by holding delete down. Maybe. Yes, I want to delete everything. And let's type in a system of inequalities. So you hit tab, and right here where it says equals, we're just going to delete back, and all these inequality symbols will pop up. So I am on page 261, and I'm just typing in the example problem 4. So it says y is less than or equal to, so I'll choose that, negative x squared minus 9x minus 2. And if you notice, it shades it nice and neat for us and gives our inequality. Then I have another quadratic, so I hit tab, and that one says, delete back, it's greater than x squared minus 2. Yep. And I hit enter and graph it. And so now my intersection, if you can see, is right shaded in this darker region. Both of them are dashed lines because it is greater than and less than, so that means all the values on that are not included. Now, where would all the points be that make this system true? So instead of just having 2 intersection points maybe up at the top of where this max is and down here where this min is, it's this darker shaded region all the way in there. Any point that's in there would make both equations in this inequality true. So they'll ask you questions like, does the solution, give me a point where the solution lies. So as long as you're picking any point in that darker region there, you'll get the answer correct. So I hope that's enough examples. You can look in your book. There's a couple more to help you with, and work together if you need to. I am giving you the odds, so you have the answers in the back of the book for the substitution ones. The graphing ones, you need to use your calculator and just look for the solutions. So I hope you have a great day. Sorry I can't be here. My kids are at the doctor's office. If you have any questions, you can come see me. I'll be here later today after lunch. So have a good one.